Dear student, in this lecture, I shall discuss the topics which are first postulates of quantum mechanics, acceptable or well-behaved functions, normalized functions, orthogonal functions, and how to normalize a wave functions. So let us discuss one by one. Now first discuss the first postulates of quantum mechanics. So according to first postulates, all the informations regarding the observable properties of a system are confined in a mathematical function psi x, y, z and t, which is in general a complex quantity but which is a function of real variable x, y, z and t. Now let us understand these postulates. All the information regarding the observable properties. Now, what are observable properties of a system? The observable properties of a systems are, that is, observable properties or measurable quantity. The observable properties of systems are its position, its momentum, its energy, angular momentum, etc. These are observable. These are measurable. This can be measured. So all these observable property, that is energy, momentum, etc., are present in a function which is called wave function. This is the first postulates. This is very simple. In the first postulates, that is, first postulate says that all the information such as energy, momentum, etc. are present in a function which is called wave function. That wave function is in general a complex quantity, but it is a function of real variable x, y, z and t. So in short, first postulate defines the wave function. That is, wave function contains all the informations. Now, a quantum mechanical system may have different wave functions, but all the wave functions do not give all the informations. That's why all the wave functions are not acceptable. Means those wave functions gives all the informations regarding these observable properties, gives all the information such as energy, angular momentum, are called acceptable wave functions. I repeat, those functions which gives all the informations are called acceptable wave functions. Now, acceptable wave functions are those which follows certain conditions. Acceptable wave function also must follow some conditions. What are the conditions for acceptable? For acceptable wave function, it should follow certain conditions. Number one, it should be single valued. That is, it should be psi should be single valued. That is, psi should be single valued. See here, suppose this is y, this is x, right? So this is the function, So for this function, so for a given value of x, y is this value, y is this value, this value, this value. That is, for a given value of x, y has multiple values. So this is multi-valued function. But see, this is the, suppose y, this is x, this is the curve. So this is a single valued functions. So psi should be single valued. Second, psi and its first derivatives should be continuous. First single valued, second should be continuous. Psi and its first derivatives first derivatives should be continuous. That is, suppose this is y, this is x, this function is a continuous function. But see here, this is y, this is x, these are discontinuous functions. And its first derivative, suppose the first derivative, so this is dy by dx, dy by dx, and its first derivative also should be continuous. Single valued, continuous, and number third, it should be square integrable. Number third, it should be square integrable. It should be square integrable. That is, integration of square of absolute value of psi. Say, this is the, say, psi x, y, z, t. This is absolute value of psi. Square of absolute value of psi. Integration of absolute value of psi over the whole configuration of space, and whole space there is minus infinity to plus infinity in the x direction, minus infinity to plus infinity in the y direction, minus infinity to plus infinity in the z direction. That is integration of absolute value of psi, integration of square of absolute value of psi over the whole configuration, that is dx, dy, dz should be finite. That is called, it should be square integrable. In short, in shorthand notation, we can write the integration of this minus infinity to plus infinity. So this is psi qt square d tau should be finite. D tau should be finite. That is, where q equal to x, y, and z, and d tau equal to dx, dy, dz. In direct notation, one of the direct notation, it should be written like this: psi should be finite. So these are the conditions should satisfy a acceptable wave functions. I repeat, that is, acceptable wave function should follow these three conditions. Now those acceptable wave functions follow these conditions. They are not only acceptable, but also they are well behaved function. I repeat, those function who is satisfied these three conditions, they are not only acceptable, but also they are well behaved functions. So this is the definition of acceptable and well behaved function. Next is normalized function. Now those functions which satisfied the following conditions are called normalized function. Suppose a function psi should be normalized if it satisfy the following condition. That is integration of minus infinity to plus infinity psi star psi dx equal to 1. A function psi is normalized is satisfy this condition, where psi star is the complex conjugate of psi. Suppose if psi is a complex quantity, generally psi is a complex quantity. So when complex quantity is multiplied by its a complex conjugate, we will get a real value. So a function will be normalized if it satisfies these conditions, or it can be written directly or in direct notation psi equal to 1. Second, orthogonal function. Two functions are orthogonal to each other if they satisfy the following conditions. Suppose two functions psi 1 and psi 2 are orthogonal to each other if they satisfy integration minus infinity to plus infinity psi 1 and psi 2 dx equal to 0, or in direct notation psi 1 psi 2 equal to 0. So in normalization it should be 1, product it should be 1, but in case of orthogonal function, their product, two functions are orthogonal to each other if their product integration gives 0 value, that is they are cancel each others. Now what are orthonormal functions? Orthonormal function, the two functions say psi I and psi j, if they satisfy both the normalization condition as well as orthogonal conditions, are called orthonormal functions. I repeat, two functions psi I psi j if satisfy both normalization condition as well as orthogonal conditions are called orthonormal functions. So for number one, for normalization integration of minus infinity to plus infinity psi I psi j dx equal to 1, where when I equal to j. Number two, for orthogonal integration of minus infinity to plus infinity psi I psi j dx equal to 0. So this is normalized function, orthogonal function, orthonormal functions. A function may not be normalized, but it can be normalized by multiplying a normalization constant. Let us take the example. Normalize the function psi equal to x square over the integral. Over this integral, we have to normalize this function. This function is not a normalized function. So this function can be normalized by putting a normalization constant. Solution. Let n be the normalization constant. Now multiply this normalization constant, we get the normalized functions. Therefore, the normalized function will be nx square. Now, let our next job is to find out this normalization constant. Let us find out the value of normalization constant. So under normalization condition, what is normalization condition? That is integration of minus infinity plus infinity psi star psi dx equal to 1, where psi is a complex quantity. If psi is a simple one, then it can write easily, you can write minus infinity plus into psi square equal to psi square dx equal to 1. If psi is simple, this is. If psi is complex, this is. Now here psi equal to x square. X square is not a complex quantity, so we can, under this normalization condition, we can write integration here minus infinity plus infinity, but here integration from 0 to k. So what is the psi normalized function? So this is the normalized function, n x square dx equal to 1. Now simple mathematics, we do this simple method, or n square is a constant quantity, comes out of the integration 0 to k x square, that is x to the power 4 dx equal to 1, or n square x to the power 5 by 5 0 k equal to 1. This is a simple integration, or n square k to the power 5 by 5 equal to 1, or n equal to 5 by k to the power 5 half. So this is the value of normalization constant. Therefore, the normalized function is 5 by k to the power 5 to the power half x square. So this is our normalized function. In this we can normalize a function by multiplying a normalization constant. So we have learned in this lecture first postulates of quantum mechanics, acceptable and well-behaved functions, normalized functions, orthogonal functions, orthonormal functions, how to normalize functions. So I think your purpose will serve by watching this video. So thank you for watching this video.